Hi, this is lesson 10.2, use combinations in the binomial theorem. Our big question here is how do you determine the number of distinguishable permutations, so this is a word that we'll talk about, in the letters of a word. So here's our frame, combinations, and this is about figuring out the number of ways events can occur when order, now order matters was yesterday, so I need to add a couple of words in here, when order does not matter. Okay, we're talking about when order does not matter today. So make sure you've got that does not matter in there because it does make quite a difference here. So we're figuring out the number of ways events can occur when order does not matter. Okay, so the first main idea here, the number of combinations of R objects taken from a group of N distinct objects is denoted NCR. So N is the total number of objects, R is how many we want. So NCR can be simplified like this, N factorial divided by N minus R factorial times R factorial. That's how we can simplify. So let's look at a problem. It says you're picking 7 books from a stack of 32. So let's put on here right now what my N is and what my R is. My N is always going to be the bigger number. So 32 is my N and 7 is my R because I'm taking 7 from a stack of 32. If the order of the books you choose is not important, so it tells us right there, it says order is not important. How many different 7-book groups are possible? So we know we're going to do 32 total, and we want 7. So 32C7. And we're just going to simplify that. So my N is 32, so I'm going to do 32 factorial over, and on the bottom, I'm going to do 32 minus 7 factorial times 7 factorial. And if you put that in your calculator and simplify, you get 3,365,856. So that is quite a large number. Okay, example 2 here. Decide to multiply or add combinations. So we're going to be doing a couple combinations and we have to decide if we want to multiply them or add them. So the local rental store is having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies. You want exactly 2 comedies and 3 family movies. Okay, so you want both of these. How many different combinations can you rent? So there are multiple events occurring here. I like to think multiple events tells me to multiply things. Whenever I have multiple things that I want to happen, I'm going to multiply my things together. So I have 12C2 because I have 12 comedies and I want 2 of them. So I have 12C2 times, for my family movies, well, I've got 9 family movies, and I want 3 of them, so that's 9C3. So we've got 12C2 times 9C3, and if you simplify that all in your calculator, and put it right in there, you'll end up getting 5,544. And again, we multiplied those 2 things because we wanted multiple things to happen. Our next problem is you can afford at most 2 movies. How many movie combinations can you rent? So at most 2 movies means you can have 0 movies, 1 movies, or 2 movies. You can't have all 3 of them. You can have 0, 1, or 2. So only one thing's going to happen. You're only going to get one of those 3 things. Since we're only going to have one of those 3 things happening, that's when we add. Remember up here we multiplied because we wanted multiple things to happen. Down here we only want one of them to happen, so we are going to just add. And we have to figure out what number comes first, and the first number is going to be our total options. So we have 12 comedies plus 8 action, that's 20, plus 7 drama, that's 27, plus 5 suspense, that's 32, and 9 family movies, that gives me a total of 41. So down here, it's going to be 41C0, or you could have 41C1, or you could have 41C2. So we would have to find those separately, which is 1 for 41C0, that's 1, plus 41C1 is 41. There's 41 ways just to pick one. Plus 41C2, there are 820 ways to choose 2 of them. So 1 plus 41 plus 820 is 862. And you should be able to write this small enough to fit in your blanks. I just can't write quite small enough with this pen. So my final answers for both of these, this one was 5,544. Multiple events, so I multiplied. This one was 862. I only wanted one of my things to happen, so I added them together. Okay, here's our next example. A popular magazine has 11 articles. You want to read at least 2 of the articles. How many different combinations of articles can you read? So at least 2, let's think about it. That means you could read 2, or you could read 3, or 4, or 5, or 6, or 7, or 8, or 9, or 10, or 11. So you could read quite a few of them. So our solution here, is for each of the 11 articles you can choose to read or not read the article. So there are 2 combinations for each of them. So there are 2 combinations for each one. 2 for each one, well, that would be, if we think about it, 2 times 2 times 2, 11 times. So that means 2 to the 11th power total combinations. Okay, because I have 2 options for each time. I can read or not read it. So 2 times 2 times 2, 11 times would be 2 to the 11th. That's how many total combinations you have. If you read at least 2 articles, you do not read only a total of 0 or 1 articles. So what you could do is you could do 11C2, 11C3, 11C4, 11C5, all the way up onto 11C11, but that's going to be a lot of work. You know that you don't want 11C0 and 11C1. Those are the ones you don't want. So we're going to take our total possible combinations, and that's 2 to the 11th, and we're going to subtract the ones that we don't want. We don't want 11C0, and we don't want 11C1. Those are the 2 we don't want. So 2 to the 11th power is 2,048. And we're going to subtract from that, well, 11C0 is 1, and 11C1 is 11. 1 plus 11 is 12. So we're going to subtract those 12 that we don't want. Then that would leave us with 2,036. So there are 2,036 possible ways. And that would be the same thing if you had taken 11C2, 11C3, 11C4, all the way up to 11C11 and just added them all together. This is just the quicker way of doing it. So next we're going to look at something called Pascal's triangle. So this is about Pascal's triangle and how it relates to combinations. So if you could flip your frame over and fill this in, Pascal's triangle is about Pascal's triangle and how it relates to combinations. All right, let's look at this first main idea, and this is just really how we construct the Pascal's triangle. So what you need to remember is the first and last numbers in each row are 1, and every number other than 1 is the sum of the closest 2 numbers in the row directly above it. Okay, so these numbers on the outside are all 1s. Okay, and we find these other numbers by adding the 2 above it. So 1 plus 1 would give me 2 here. 1 plus 2 would give me 3 here. 2 plus 1 would give me 3 here. Then we'd have 1s on the outside of the next row, and we'd add these together to find the ones below it. But let's see how we do this as combinations. Okay, so as combinations, 0, it's always a number C0 for the first spot. So this is going to be C0, C0. If I can write this. It's going to be 1C0, 2C0, 3C0. So as you see, anything C0 is always 1. There's always only one way to choose 0 things. Okay? The next row, 1C0, and then you're going to have 1C1. So the next row is always going to be 1. So I have 2C1, 3C1. And if you put 2C1 into your calculator right here, 2C1, that'll give you this value. But 2C1 is 1 plus 1, which is 2. Okay? The next one, we have 2C0, 2C1, and then the next number would be 2C2. And 2C2, there's only one way to choose two things, so 2C2 corresponds with the number 1. Okay? The next one, I've got 3C0, 3C1. I'm going to have 3C2 and then 3C3. So we've got 3C2 and 3C3. Okay, and you could plug those into your calculators. You could put this in to find this number and this into your calculator to find this number. Or you could also say 1 plus 2 is 3. So 3 goes here. And then 2 plus 1 is also 3 for the next term. So this triangle is very related, combinations and the numbers in Pascal's triangle. So this next one says find row 7. So we know row 7 is going to be 7C0 first, because we always start with 0. Then it's going to be 7C1, 7C2, 7C3, 7C4, 7C5, 7C6, and then 7C7. You could go through and put all these numbers in your calculator, but I know a couple of the values right away. I know the first number is 1, 7C0 is 1. 7C7 would be 1 as well, because there's only one way to choose 0 and one way to choose 7. And then the rest of them, just put into your calculator. 7C1 is 7, and we know the other side, 7C6, is going to be the same thing. 7C2 is 21 if you put it into your calculator, and we know 7C5 is also going to be 21. And then 7C3 is 35, and 7C4 would also be 35. Okay, let's do a problem using Pascal's triangle. So it says out of five finalists, your class must choose 3 class representatives. Use Pascal's triangle to find the number of combinations of 3 students that can be chosen as representatives. So we know we have 5 finalists, so we're going to use row 5 here. So we're going to do, for row 5, we know it's going to be 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, and 5 choose 5. So I know my first and last numbers are both 1 automatically, and if you put this in your calculator, 5C1 would be 5. 5C4 we know would also be 5. 5C2 is 10, and so 5C3 also has to be 10. So the value that we want here, we got 5 finalists and we want to choose 3. So the value of 5C3, because we want 3 of them, the value 5 choose 3 is, this word of should be before that, so the value 5 choose 3 is the 4th value in the 5th row of Pascal's triangle. And it's the 4th one because we have 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3. So it's the 4th value here. You've got to keep that in mind. Therefore, 5 choose 3 is 10. So our solution, there are 10 combinations of class representatives. So what students would make mistake on here is they say, oh, choose 3 people, that'd be right here. You've got to remember the first one is always choosing 0. Okay. So now we're going to look at the last frame here, our binomial expansion. This is about how we simplify a plus b to the nth power without multiplying it out. Here's the key, without multiplying it out. What you could do for some of these is use FOIL and then use FOIL again and distribute some more and distribute some more. But we're going to learn a quick way to expand binomials. Okay, so our binomial theorem is for any positive integer n, so n is your exponent. The binomial expansion of a plus b to the nth looks like this. Okay, so we're going to do n choose 0, n choose 1, and all the way to n choose n for our coefficients. And then you start with your first thing and raise it to the nth power. So see, a to the nth. And then you do a to the n minus 1. And then all the way down to a to the 0. And then your second thing, your b, starts to the 0th power. And then it goes to the first power. And it works all the way up to the nth power. And what you should notice every time is your two exponents have to add up to your power. So these have to add up to n. These two would add up to n. And these two would add up to n. So notice that each term in the expansion of a plus b to the nth has this form. It has the form NCR times a to the n minus r times b to the r, where r is an integer from 0 to n. So the best way to learn this is really just to practice it. So we're going to do an example here. Expand a power of a binomial sum. So we're going to use the binomial theorem to write the binomial expansion of this. Okay? So look at 3 as your exponent. So we know our coefficients are going to be 3 choose 0, 3 choose 1, 3 choose 2, and then 3 choose 3. Okay, so I'm going to write that out here. I know I'm going to have, give myself some space. 3 choose 0, leave a lot of space here. 3 choose 1, I'm going to leave some more space. 3 choose 2. And then I'm going to leave some space. 3 choose 3. Those are going to be my coefficients, the number in front of the variables. Okay, next, I'm going to take this x term and give it the third power and then work the way down. So I'm going to say times x to the third times x to the second times x to the first times x to the 0th. Then I take the second one, 4, and I start with 0 and work my way up as the power. So times 4 to the 0th. I'm going to have a plus sign in the middle because there's a new term. 4 to the first, plus sign in the middle. 4 to the second, plus sign in the middle. And then this one is going to be 4 to the third. And notice every single time, 3 plus 0 is 3. 2 plus 1 is 3. 1 plus 2 is 3. 0 plus 3 is 3. Every time your exponents must add up. So now let's simplify. Okay, so let's do some simplifying. 3 choose 0 is 1, and I know 3 choose 3 is also 1. 3 choose 1 is 3. We have plus 3. 3 choose 2 is also 3, so plus 3. So I just simplified those first. Okay, x to the third is just x to the third. 4 to the 0th is 1, so it goes away. So I have 1 x to the third. The next one, x squared stays x to the square, x squared. 4 to the first is just 4. So I'm going to have this times 4. Then I've got times x squared still. Okay, my next one, x to the first is just x. 4 squared is 16. So I've got times 16, and I've got times x. And then my last one here, x to the 0th, well, that's just 1, so I don't need to write that. 4 to the third power is 64. So now I got times 64 here, and I need my plus sign in the middle. All right, so let's just simplify now. X to the 1 times x to the third is just x to the third. Plus 3 times 4 times x squared is 12x squared. Plus 3 times 16 times x is 48x. plus 1 times 64 is 64. And this is your final answer. And that will definitely take some more practice. We'll do a lot more practicing on that in class. Okay, the next problem here says expand a power of a binomial difference. So notice we've got a subtraction sign. So use the binomial theorem to write the binomial expansion of 2m minus n to the fourth power. And what you need to remember is that minus n right there, you can think of that as negative 1 times n. I like to think of it as negative 1 times n. So let's write this out, and I can't write quite small enough on this, so you should be able to write small enough to make it fit in your blank. It won't be able to fit on mine here, though, because I can't write small enough. So we know we've got the fourth power, so our coefficients are going to be 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4. We know those are going to be our coefficients. Now we're going to have 2m, I've got my 2m here, to the fourth power and work our way down. So I've got 2m, and notice how I'm putting parentheses, to the fourth, and I've got 2m to the third, and I've got 2m to the second, then I've got 2m to the first, and then I've got 2m to the 0th power. Okay. Next, I've got negative 1 times n, and I'm going to start with the 0th power and work my way up now. So, negative 1, negative 1n to the 0th, plus, separate terms here, negative 1n to the first, plus, separate terms, negative 1n to the second, plus, again, separate terms, negative 1n to the third, plus, because here's a separate term, and over here I'm running out of space, negative 1n to the fourth power. Okay, so now we need to just simplify this. Lots of simplifying to do here. So let's look at our coefficients first. 4 choose 0 is 1. 4 choose 1 is 4. 4 choose 2 is 6. 4 choose 3 is also 6. 4 choose, not 6. 4 choose 3 is not 6, it's 4. And then 4 choose 4 is 1. So there's my coefficients. I'll put my plus sign in front of all of them because that's where my new terms start. Okay. Now I've got 2 to the fourth times m to the fourth. So times 2 to the fourth, m to the fourth. Okay. Negative 1 to the 0th and n to the 0th, well, that's just 1, so I don't need to worry about writing that. The next term here, I've got 2 to the third, got 2 to the third, m to the third, negative 1 to the first, and n to the first. So let's write that out here. So times 2 to the third, m to the third, negative 1 to the first, that's just going to be negative 1, and then n to the first is just n. My next one, I've got 2 to the second, m to the second, negative 1 to the second, n to the second. So all of those numbers have to be raised to the second power. So times 2 to the second, m to the second, negative 1 to the second, n to the second. Okay. The next one here, I've got 2 to the first, m to the first, well that's just 2 times m, negative 1 to the third, and n to the third. So I've got times 2 times m times negative 1 to the third times n, I'll write this right below it, to the third. And then my last one here, 2m to the 0th, well, that's just 1, so I don't need it. Negative 1 to the 4th and n to the 4th. So I've got negative 1 to the 4th, n to the 4th. Well, let's do some simplifying now here. 1 times 2 to the 4th is going to give me 16, and m to the 4th stays there, so I have 16 m to the 4th. Next, 4 times 2 to the 3rd times negative 1. Well, that's going to give me a negative 32. Then I've got my m to the 3rd times n. The next one here, 6 times 2 squared times negative 1 squared. Well, that's going to give me a positive 24. And I've got m squared, n squared. My next term, 4 times 2 times negative 1 to the 3rd. That's going to give me a negative 8. And I've still got m times n to the 3rd. And then my last term here, negative 1 to the 4th times n to the 4th. Well, that's just going to give me a plus n to the 4th. So here is your final answer. 16m to the 4th minus 32m to the 3rd times n plus 24m squared n squared minus 8m n to the 3rd plus n to the 4th. So that would take forever to FOIL it out. This is definitely a quicker way, even though it does take a while. And our last issue here, our last problem that we need to solve, find a coefficient in an expansion. So remember, the coefficient is the first number. So find the coefficient of x to the 5th in the expansion 2x minus 7 to the 9th power. So here's what we have to remember. Each term in this expansion has 9cr times 2x to the 9 minus r times negative 7 to the r form. So that's what my form would look like. So the term that would have x to the 5th, well, 9 minus what would be 5? That would be 4th. So our term occurs when r equals 4. So what we really want here is we want 9 choose 4. This number has to be the number you want as your x variable, so x to the 5th minus 1. So that's 9 choose 4, and if you put that in your calculator, you get 126. So this is the end of the video. Please make sure if you have any questions that you star them so we can go over them in class tomorrow, and have a great day.